Hey there guys, mining game update day 7. So this has been the 7th day that we've tried to learn how to code or fiddle with the game in some way. I've been off for the last 24 hours because what I was doing instead was Paradox Interactive, a company which I love, who I stream the games of kind of regularly, and who I really admire in a lot of ways. I actually moderate their Twitch channel, and they're having a Paradox convention right now, so they're doing a lot of Twitch content, so I need to be around for that. But enough about that. Let's get into the code and let's get into what we've been doing. Now, stick around. Okay, I'm gonna go into I'm going to put like a index of timestamps in the info so you can skip ahead to the new stuff. But I said at the end of last run through that I would go through my biome generation script to sort of show how this is going to work. Okay, so this generation, which happens every time you start the game with different results. Okay, so if you weren't here, what I'm doing here is each of these, so every time the game generates, it's going to generate 4 independent mines for you to be able to mine in, rather than just one. Okay, and that will allow you to get things from multiple locations, which will be far more interesting. Let's ignore this green brick for now. And you might notice a thing here called detector. We'll show you that at the end of explaining how biome generation works. Okay, so here's how biome generation works. Now please note a lot of this code is way too large and it's not efficient, but let's go through it anyway. So the first thing we do is we create the table X, which is something that we've been doing even in here. This exact same start. Okay, table X and RNG equals random.new. Okay, these things allow us to make sure that there isn't anything, the table X stuff, anything here is allowing us to make sure that there isn't already a block in the position that we're trying to make. Okay, so that's good. And this RNG thing is creating a new seed for us to work with. Okay, but then we've got these two tables. So table biomes names and table biome status. What are they? Well, table biomes names is a table where each key corresponds to a part. Okay, so they correspond to the parts which exist in replicated storage biomes. All of these. Okay, these are in no way a final list or anything like that. It's just what I'm screwing around with right now. And then this checks whether or not they already exist in the game. So at the start of the game, they're all set to false. We set them ourselves. Yep. So then we also create a new table called table biome success, which should be biomes if we're using biomes elsewhere, but that's okay. And it's an empty table. And then we're just creating a local variable called biome check. All right. Then we get to use our very first repeat loop. We've never done this before, but basically repeat until biome check is equal to 4. Biome check starts at 0. First thing that biome check loop does is increases biome check by 1. So biome check is now 1. Local. We've made a new variable. That new variable is equal to RNG, so random.new, next integer 1 to 14. Get us an integer, so a whole number between 1 and 14. Okay? So it does that for us. So let's say it gets 2. And then set got biome to false. While got biome is equal to false, do this stuff. Alright. Now this is what is normally called a for IV in pairs loop. And so normally you would see it like this. Okay, this is a good example that's used. Okay. But instead, what I've done is, this is exactly the same, it works exactly the same. I've just changed them so that way they're more understandable. For key, value, from this table, in pairs. Okay, the reason why in pairs is because we have both a key and a value, and we want to grab them both. Okay, so for both of these things, do. Firstly, and this should be around the other way, so let's actually do that. Screw with code right now because it's bugging me. Okay, so if value 1 is equal to the RNG thing that we did. So if value 1 is equal to 2, then do this. Okay, it's not, so we get the next value. If the next value is 2, is that equal to 2? Yes. Then what we do is we go into table biome status, so that's this one, and we see if the table biome status entry for 2 is equal to true. It's not, so then we go instead to here. If table biome status check is equal to false, it is. We don't need to really have this, but it's because I was fiddling around with stuff, so we could do just else. Literally, we could just do else, so we could remove that. Then go to table biome success, so this table, biome check. So biome check is currently 1. So for table biome success, key 1, make it equal to value. And value is the value of key 2 in table biome names. So it's now putting this as the first entry in this table. So this table will now essentially have this in it. Okay. All right. So that's what that's doing. So that's putting that in that table. Okay. Then it's setting this to true because we've gotten it. And then we've set got biome to true. All right. I still don't know why I'm doing this while got biome equals false loop. It's not the right loop to use in this situation. But that's okay. We literally don't even need to use it, I don't think. Yeah, because we set both to true regardless of what happens. No, okay, there is a reason why, but it's fine. Anyway, so then biome check is equal to 1, so we go back up to the top. So let's see what happens if we do this again. So we're back up the top. Biome check is now equal to 1. Biome check is now equal to 2. Local check, let's get a new integer. Rather than getting 2, we'll get 2 again, because I want to show you what happens. Set got biome to false, while got biome is false, then go back into that table and see if see how it goes. First thing it does is grab 1. 1 is not equal to 2, so we just go back up to here. 2 is equal to 2 though, so we will check this table. So we'll now check this value, which is currently true because of the way it was set up last time. So then we actually remove 1 from biome check, set got biome to true, and print yay. Now I'm just going to test something. I'm pretty sure we don't need to do any of this, and it's kind of annoying me. So if we've screwed this up, it'll become really obvious. But I don't think it will. So yeah, that's what I thought. It's for the old. So when we were creating this in the first place, we did some really weird stuff. Did we remove print yay? Sorry, I just want to sort of double check some stuff. No, we didn't. Okay, so we haven't had a print yay loop. I just want to hit a print yay and then I will be happy. So print yay is, there we go, cool. All right, so that worked fine. And that will be much faster now. Okay. Anyway, that's what that does. Next up, for IV impairs. So this is your, it's the exact same loop, okay? It's the exact same. It's the exact same as for key value impairs, okay? For key value in pairs, this table, print those values, okay? Which is what it does here. 1 is fabric, 2 is glass, 3 is bricks, 4 is cheese. Okay? Then set those values in that table. So we don't even need to do this anymore. Like, seriously, we know that it works, but I like to print it nonetheless. So loop 1 is equal to the value of the key of 1. So this table's key of 1's value is now equal to loop 1, so on and so forth. So that is now equal to, loop 1 is now equal to fabric. Okay. Then the generation script that we already use is still here. It's just that instead, what we've got here is now it's grabbing that loop 1 variable and setting it all that way. Okay. Now, this is actually bad. What we need to be doing instead is, let's do local clone is equal to loop 1 clone, capital C. Then we do clone dot position equals vector 3 dot new x y z. Clone dot parent is equal to game dot workspace dot initial box. Okay, that's actually how we do it properly, but right now we are not doing it that way because I have been lazy and haven't put this code in instead. But I can show you that it's not going to break anything if I do it that way. So in theory, this would break things, right? If this didn't work, because we definitely hit this first loop for quite a bit. So I'll show you. Nothing changed. Everything still worked fine. Cool. So that's our biome generation script. All right. And now what we've done is we've made some slight modifications to how this works. You might notice that we now go from minus 6 to 30. And then we go from 30 to 42 to 78. Okay, and that's doing this separation. Okay, and the reason for that gap is for this. Okay, this unmineable. Alright, unmineable stuff. And we've thrown it into the block generation script, so no matter how deep you go, the unmineable stuff is still there. Sorry about the bad lighting. I've been fiddling with lighting a little bit, and yeah. Okay, 13 minutes in. Let's talk about what I've been trying to do instead. So there's two features that I'm working on concurrently, and I'm not stuck particularly. It's just it's a bit painful to work on at the moment. I feel like I'm just doing it very, very badly, and so it was getting me down, and so I decided, let's stop working on that. We just need to change of pace. So instead of working on those two features, which were a feature that I won't name because I would prefer to show it off in the next video, then what about or the other feature, which is caves? I've already talked about caves / dungeons / everything like that before. So yeah. So rather than working on those, what we did instead was work on another part of the roadmap. Okay? And that is called detector. And rather than me explain what detector does, which I will, but let me show you what detector does. Now, this is nowhere near how it's going to be perceived. So remember that green block? Let's assume that that is a very rare ore, okay? And we've created, and we've told the game, which we will be able to do at some point, that we really like this block, okay? It's a rare block and we really want it. So we need to make sure that we can find that block if there's a block nearby that is of that type, okay? So how are we going to do that? Well, currently it's not set up to only work in the biome that you're in, but let's imagine that we have set that up. It's fairly trivial to do that. So let's mine a little bit, okay? Let's just mine straight down. All right, the detector doesn't have a light, but let's use it and see what happens. Okay, let's try that again. Okay, so that didn't really do much, but it did create this little glow thing. Let's make a little bigger area. Okay, so we definitely saw something sort of coming from this direction. It was green. That's pretty cool. And it made a little radar noise. Alright, well, let's go over here, which is completely the wrong way to where we need to be going, but that's okay. I'm super lost right now, which is good. Let's use the detector, and yeah, that's unfortunately sunlight bleeding into the cave, which we'll definitely fix, but... Okay, so we now know that it's over there somewhere, so let's head on over to there. Okay, actually let's go this way, and we go, okay, what about here? Okay, that looks about good, right? So now if we go this way, what about trying here? Okay, it looks like we're pretty much lined up. Exactly. Alright, that's interesting. Okay, so it's above us. Alright, let's well, I can see the glow from it, so... Okay. So, what's up there? Okay, find it any second now. I created the glow on this way too large, but that's okay. There she is. Alright. So we've got this green ore. I have to turn off the spotlight when it's not working. So, but that's okay. That's not a problem. It's easy to do. So yeah, right now the spotlight is on even when it shouldn't be. But okay, there's our precious ore. Alright, so how does that actually look in practicality? Alright, let's run all the way back this way. Cool. Alright, if we were directly in front of the ore like this, and we pull out our detector, that looks frickin' awesome. Okay. And likewise, and obviously as you've already seen, it clearly follows you around. So if I go on the other side of it, and we switch tools, okay. Now, what's happening there when I'm sort of like going backwards? Well, what it does is it's going to you, and it takes time to get to you, so it's kind of like a projectile, right? And it's just going to take time to get to you. Now, we did some pretty interesting things. Okay, first off, one of the things that I want to do is... actually, I may have screwed this up. Yeah, I think I totally did. I'm going to stop, and I'm going to make a change to it while I go and show you what's going on. So what I like to do is I like to comment. One of the new things that I'm doing is commenting out old code rather than building on top of it, so that I can sort of show you guys my natural progression So I created this tween service, and that's what it looked like originally. And then we sort of went in a little bit more over here. This is all using Alvin Blocks' tutorial mostly for tween stuff. Link will be in the description. But basically what we do is we now have a tool, our detector tool. Yeah, okay, I need to fix this, but that's okay. Let's do that. And then we can fix this. Okay, so player equals game.players.localPlayer, because as a tool, we can get the local player very easily. Tool is equal to script.parent, and we set this can activate as equal to true. Tool activated connect. This is outdated. We're doing it on equip before just to test it. Activated tool. Okay. If can activate is equal to true, then we do all this stuff. Okay. So can activate is defaulted to true. Then what we do is we get this magnitude variable. Okay. So magnitude variable is a distance between the 2 points. So we get the player character's humanoid root part position, and we minus the, and we've done a manual thing for this, but we can do it based on generation. That's easy peasy. There's nothing we need to worry about there. So we're doing it manual for testing purposes, but we can set it up based on ore generation and stuff later on. And we'll probably test that with gold, because gold is our 1% thing. Eventually, this will need to be built out to only detect the closest of them, and stuff like that. But that's fine. It's fine. Which means we'll have to fiddle with some things, but that's okay. This is not the ore. Okay, that's the other thing. This is, it's just the detector part. So then we print the magnitude, which is just what you can see here. This is the magnitude variable. Okay, so when we're really close, it's like 8 or 7. When we're further away, it's like 90. Okay, and then it says if magnitude is less than or equal to 100, then ping time is equal to 2. Okay, basically meaning that ping time's minimum is 2. Else, ping time is equal to magnitude divided by 50. Okay, and what do we use this ping time for? And we've printed it here. Okay, so 2, 2, 2, 2, 2. And we've sort of written some stuff here, but it's kind of less useful. That was when we were developing. So we set can activate false. Cool. Set the local sound to, instead of doing this, what we're going to do now is dot sound. Cool. I was wondering why there was an issue there. That will be way better now. Cool. So we've now got our sound. It's now attached to our detector. Local tween service. Okay, so this is a variable that we're stating ourselves. Is equal to game.getService tween service. Okay, then we want to create some information, which we do as tweeninfo.new, and we have to give it 5 variables. Okay, firstly is the length. How long in seconds in time will this play? Okay, so how long will it take for this thing to go from where it is to where you want it? Okay, there, and we've set that to ping time, which is 2 for closer, and then further away, which I'll show in just a little bit. So then there's a thing called easing. Easing is how the animation plays. We just set it to linear right now. I played around with a couple other ones like bounce and stuff, but it just doesn't work well. Linear is the best. Sine was a close second. Then easing direction. I don't really know what this plays as a role. I'll fiddle with it more later. The number of times the tween will repeat. Originally we had this as multiple times, but the tween doesn't update its variable check between each repeat, so we've got to put it in a loop. We don't want the tween to repeat back. So what this means is if we had this on as true, it would go to us and then away from us. Okay, so let me show you what that does, because it'd probably look really cool, actually. Yeah, that's what we've got set up. So if we set that to true instead, it'll come at us much faster, but that's okay. I think it's on there. There it is. Okay. So now, instead of just coming towards us, it will do this. That's pretty cool, right? That's super cool. Anyway, so we've got our sonar and it works. Okay, cool. So that's what true would do there, and the rest is a delay between each tween. Now we don't need to set a delay between each tween because we're limiting the speed of how frequently we can call this, because we're not repeating it. Basically, we don't need to create a delay anyway. So then we've got this thing called part properties. So what are we actually doing? What is the default part property that we're working with? And the default part property we're working with is C-frame. So we could have used position, but position was funny and not working properly. So instead we use C-frame, which apparently just does work properly in cases where position doesn't. So that's fine. And then we do tween is equal to tween service create. And the first thing that we do is we've got to give the tween service the thing that it's tweening, what it's using to tween with, so that's this stuff here, and then what its starting, what its finished properties should be. Okay, so it takes this part and then grabs the properties we've listed here and changes them over time to what we want. Okay, and then just play it. Alright, now we've got this, which I love, which is ping time, because we're using that variable we created before, plus 0.2, just to add a little bit of delay stuff, to just sort of make sure you can't, when you're activating it again, it's not, like it's completely finished the first one. Okay, and then this is once again a hack, that's okay, we don't need to worry about this. This is very easy to do even when we're not doing this manually like this, but resetting the position to the part of the thing that we need, and then setting can activate back to true. Okay. So the last thing that I wanted to sort of show, and this has been a long video, if you sat through this, thank you. I'm sorry that I promise more future videos will be slower. Okay, so we know how long this takes, right? It's really slow when it's close because it's taking 2 seconds. Okay, whereas if we go back here, okay, it's going much faster. I love that speed. I think 2 is the best speed, honestly. So, but if we mine, remember that thing about slower. Oh, also, now that we've fixed that, positional audio. Okay, which is what the other thing that I sort of wanted. Oh, that's why I was having difficulty. But let's say, okay, we go way far away. Okay, we can barely hear the sonar ping. All right, that's 184. We're gonna go a little bit further away than this. So this will take a little bit of time. If I really wanted to set this up, I would have done this all in advance, but it's just going to be far more noticeable. So honestly, I don't expect to make this detector work at particularly great distances. But essentially, because you're going to customize your own detector in terms of what ore you want it to detect, you'll be able to do things. So it's just going to look in the folder and see if there's a child of that exists. All right, we're gonna finish by getting to the end of this tunnel, and I'm not gonna click anymore, and then we will sort of see how the detector works from this far out. Oh, I made this tunnel super long. Cool. I've really got to up my walk speed. And can only just hear it. Huh. But check that out. Huh. Okay. And we'll ping it again. We can't ping during this time. Okay. It won't work until it's finished. Now I could do all sorts of things like rob you of being able to move once you've done that. But I think people will spam the detector while they're falling or something silly. But yeah, basically there'll be a max range the detector works, and it will be a lot less than this. But I love what I've done there, and I think it works super fantastically. I'm quite proud of the detector thing. Also, the detector takes the we haven't set this up, of course, but the detector will take on the color of the ore. So if you set a detector for like a black, black ore might be bad. Yeah, don't know how I'm gonna do it. But we will figure that out a little bit better. But basically, it'll work pretty interestingly. So thank you very much for watching. Like I said, next video will be... we will be Twitch streaming tomorrow. So if you have watched this far, twitch.tv/13characters is going to be where we will be streaming tomorrow for however long we code for. The other thing that we're doing is we're going to be focusing on sort of coding the hidden feature that I don't want to talk about until tomorrow, and caves, getting those sorted. And then, yeah, everything else will sort of work from there. The other thing is that with this script, of course, I can bake it into a miner. I don't need to do it the way it is, so I can make it so that way, like, as I'm mining, it's regularly pulsing that. I can also have one that doesn't have the detector but does have the sound. I love that you can still just hear it even that far away. That's so beautiful. But yeah. What I could do as well is I could strobe the sound over and over again. But like while you're waiting for it to come to you, which will give you a little bit better location. I love the idea of using both audio and visual cues. So yeah, I think that's going to work super well. Thank you for watching. 33 minutes. You're crazy if you have watched this the entire way through, but clearly not as crazy as I am. Bye for now.